Biscuits and gravy are finally here. Good to see you guys.
Good to see you. We need to invest in some tissues.
Yeah, can we get some tissues in here? That was the issue.
Well, I mean, if you guys went to the store, you could have got some.
Yeah, guys.
True.
Damn it.
Why do I have this thing?
All right.
Let me know why my hair's straight.
So,
Why does it go straight?
so this is the extra credit. No one else has the extra credit. This is we're good. We're solid. We're happy.
Look, I'm really frustrated. My hair is...
Cool. Anybody else? We're good? All right. Awesome.
Yeah.
All right, so a gentle reminder. If you still needed more time on the quiz, it needs to be done by after school today. Okay? Now, what's hard for me is when I have someone say, yeah, but I didn't have time to study. Yeah, you did. You had like 4 extra days.
Yeah, come on.
So that whole motto of, oh, I didn't have time to. Well,
I just didn't feel like it.
it's not every day that you get somebody barf on somebody else in class.
Be nice.
Yeah, it's only happened twice in your career.
Twice in my career.
Twice in your career with Samaya Ramadan.
Yeah, Samaya, she's awesome.
And the kid named Andrew, brother of
It's
someone
on
else.
us.
Did he collect
I don't know.
You've got brother of Ben. I do not recall his last name.
Samaya, please don't.
Aaron. We've done Aaron. I don't remember Aaron's last name.
She's
So they couldn't tag
She's
Aaron.
looking through her yearbook to find what Aaron's last name is.
You know who Samaya dated in high school, don't you?
Who? The kid that
Matthew Gray Goobler.
Ooh,
Is
the
he the one
Hey.
from Criminal Minds?
Hey, Goobler.
He's the one from Criminal Minds.
Yes.
Oh my gosh.
Better than all of you. I'm better than all of you.
All right. So this purple sheet,
It's red cute.
this purple sheet that came out to you,
Stop.
this purple sheet that came out to you is just a.
Oh wait, that's
It-
nice.
If you wanted just to have a reference, the nice thing is I can say, hey, make sure you take a look at the purple, because everything I submit to you all is usually on a white sheet of paper. So if I ever say, hey, hey, don't remember my rules of exponents, we'll take a look at your purple sheet. Okay. All right. So how did 6B, right? That was 6B we did?
Yeah, I felt pretty good.
Let's take a look. Let's go over it. So remember, if you remember, so 6B, 6B, right? So if you remember, this unit is the unit that is based on our first of 3 capstone tests. Okay? And again, if you... Cool. All right. If you do very well, if you get a 7 out of 10, that means you got 100% on a test score. That's kind of cool. If you get an 8 out of 7, you get extra credit. You get a 9 out of 7, you get extra credit. If you get a 10 out of 7, you get extra credit. So when we give that test to you, my goal is for everybody to at least pass it. So you can at least say, go into the final exam saying, dude, sweet, I got 100% on a quiz score. Okay? Now, it's not worth quite as much as the others, but it's still, you should be able to do very well on it. And hopefully you can all pass it. And I truly feel that you can pass it without like upping everything you're doing with class. Why is that? Well, I think I'm an okay teacher. And so if you can gain 10% of what I say, that equates to 100% on the quiz.
That's not true.
Okay? So, because I teach up here and I test right here, right? I'm just kidding. Wait. No, I test up here and I teach
Why does...
down here.
Why?
All right. Questions you might have come across on 6B.
No,
You?
5?
5?
Yep. 5. Yeah, 5.
5 sounds good.
7.
Problem number 5. We got time. Hey, so this is in functional notation. Functional notation is just a fancy way of writing y, correct? I'm on the right problem, right?
Yeah.
Okay. Okay. So let's go ahead and put this in standard form, which is descending order of the exponents. Okay, make sure you bring along your whatever value. There's a positive out in front of that, right? Does everyone feel comfortable with that?
Yes.
So is it a polynomial? Yes. Even though there's fractions, it's a polynomial because we don't have the letter or the variable in the denominators. Is that okay so far? Everyone happy? Okay. So it's going to ask us, it's going to say, hey, what's the degree of this? Second degree. Okay. So the degree is second because it's raised to the second power, the highest exponent. What else do we want to know? Decide if it's a function. Yes, it's a function. And rewrite in standard form and state the leading coefficient. Oh, what's my leading coefficient?
Negative 1/6.
So my leading is going to be negative 1/6. It's this. And that's, I think, all you had to do with it, correct?
Yeah.
Okay, cool. Yay. What else? Go ahead. 3. Number 3. So number 3, we have functional notation again. That's a fancy way of writing y. 4 root x minus 2x plus 7x to the third minus 1. Item 1, I don't even have to worry about putting it in standard form. The reason why I don't have to worry about that is because I have a variable under a radical. It's not a polynomial. You're done. Okay?
Number 3.
No? Yeah.
Number 19 and 22.
19 and
So
22.
there's not even like a degree or an LC.
Nope, you're just call it gun. Say, boom, not a polynomial. We're done. It's like, not a polynomial. Drop the mic. I did that on camera.
the same as 6 then too?
6. 6 is because it's just a root 5. The x to the fourth is outside the radical. So you can have a number that's under the radical sign. You just can't have the letter under it. I'm sorry, which one? Who asked for one? Which one was it?
19 and 22.
19 and what?
22. So
Okay.
the same equations with different problems.
19 and 22. Okay. I'll do them side by side. How's that? Actually, I go even better than that. Let's go this way.
Oh, I didn't fit 27 and 29.
All right, number 19. Oops, we got f of x equals 2x to the fourth plus 2x minus 1. And then 22, you said? All right, so then I got f of x equals 2x to the third plus x squared minus 1. All right, they're already both in standard form, yes? Okay, so this one right here is a 4th degree polynomial. This is positive out front, so this graph is going to look something like this. Okay, I'm not too worried about what's going on right here. I'm worried about what's going on with the ends. Okay, so let's answer this 2 ways. As I go to the right, it goes up. As I go to the left, it goes up. Is another word for up rises?
Yes.
So as it goes to the right, it rises. As it goes to the left, it rises. Terminology seems okay. Okay, so we're going to talk about this one. As x goes to positive infinity, the function at x goes to positive infinity. That's the calculus way of doing it.
Bless you.
Look at the light.
Oh my god.
Oh, it was a flag, sorry. Are you okay? All right.
Thank you.
All right, so let's use the same thing here. As x goes to negative infinity, the function at x goes to positive infinity. Okay, cool. All right. So problem number 22 is a 3rd degree polynomial. Everyone agree that this is 3rd degree? This is positive. So a 3rd degree polynomial, anytime this is a positive number, your end behavior is going to be here. And this is what it kind of looks like. Okay?
What were you saying yesterday about a 50%?
I'd like to see one. I can't.
All right, so as I go to the right, my my graph goes to? Increases, it rises, right? As I go to the left, it decreases, falls, something like that. Okay? And then if we talk about this one, we'll say as x goes to positive infinity, the function at x, which is the y, fancy way we're on the right, also goes to where? Positive infinity. And then when we talk about this end behavior, as x goes to negative infinity, so it's going that way, function at x goes to, it's going down, so it also goes to negative infinity, right? Is that okay? Cool. What else did you come across? Yeah, Riley.
Can you do something like the bottom?
Bottom? Yeah.
It's like 27.
Like 27. Riley, do you have another one? 28.
No, I just didn't really understand how to do it.
28. 27, 28 seem good. All right. 27, we have the f at x is equal to x to the 5th plus 2x squared.
Wait.
And 28 is... Dude! You guys are so critical. Pick the wrong one, buddy. Okay. Talk to me. Thank you. All right, 27. f at x is equal to x to the 7th minus 3x to the 3rd plus 2x. And 28 is f at x equals negative 3x to the 3rd, x plus 3 squared, and then squeeze an x minus 4 in there. Is that okay? There's a 4 there. All right, let's see if we can answer this question. First thing, what is the degree of number 27? 7. So that's my degree. Okay? All right. So let's think about what the graph would be doing. This is the same graph as x to the 3rd. X to the 3rd graph looks like this. Okay? So if that graph is pretty much the same, the end behavior is going to be the same. I had a positive 1 out front. So as x goes to infinity, positive infinity, the function at x goes to what?
Negative.
Positive infinity. It's going up. And then as x goes to negative infinity, so as we're going to the left, where is the graph going? So the function at f goes to negative infinity. Is that okay? All right. Number 28. Let's figure out what degree it will be. I have x to the 3rd there. That would become x squared, and that would just be an x, right? So I have x to the 3rd, x squared, so that's now x to the 5th, x by itself. So this is x to the 6th if you multiply the whole thing out. There's no reason to multiply the whole thing out. We're just going to do that. So if this is the case, means my degree is a 6th degree polynomial. I have a negative out in front though. So this is going to do this. It's going to go downward. If that was a positive out there, it would go upward. So let's talk about this end behavior. As the function at x, as x goes to positive infinity, so as it goes right, where's this going? Okay. And then f at x goes to negative infinity. And then talk about this end behavior. As x goes to negative infinity, our graph goes to what? Negative infinity. Done. That's it. That's it. That's all.
Whenever there's a positive, like, then it's gonna be like a squiggly M thing.
If our degree is 2, 4, 6, 8, 10, 12, so it's an even number, it's either both going to open up or down. If you have a negative out front, it'll open down. Bless you. If it's positive out front, it opens up.
Okay.
Yeah.
For number 29, where it's negative out front and it's in third through the
Okay, so the exponent is actually, you have x to the 6th for the degree. You're talking about 28, right? 29. Okay, 29 is going to, the graph will, so this is what it normally would look like, but if I have a negative x to the 3rd, it's going to flip-flop and look like that. So as x goes to infinity, function at x goes to negative infinity. As x goes to negative infinity. So it flip-flops. The graph changes direction. And behavior changes. Yeah.
So wait, for what number does it do the, like, both negative and positive? Is it just for x third?
So if we know our degree, single mode screen. No, that's not what I wanted. Get out of this. Go back to single display here. So x squared, x to the fourth, x to the sixth, x to the even. Okay, even number 2, 4, 6, 8.
Yeah.
This is what it looks like for the most part as far as the end behavior. If I had negative x squared, negative x to the fourth, negative x to the sixth, negative x to the even, your graph's going to do this. Okay, so that's the rule with those. But then I go to, but then if I have x to the third, x to the fifth, even x to the first, x to the first is just going to do it. So x to an odd number, this is what the graph will look like for the most part. If it's linear, it's going to look like this. That's what that one would look like. But can you see how the end behavior is still the same? Yep. So if I have negative x to 1, negative x to the negative 3, or positive 3, excuse me, negative x to the fifth, negative x to the odd, you take this and it just does this. So it looks like that. And of course, then this one would look like this. Okay? Yeah.
How do you do the synthetic stuff again?
Yeah.
Which one was that one?
Just,
Oh, like 18?
Will you do like 14?
yeah, 14.
14. That's a synthetic one?
Yeah.
Okay. Now, number 14, you said? We have f of x means the same thing as y equals x to the 6th power plus 3x plus 4. And then I'm going to divide by x equals 2. Okay. So first off, do I have, it's in standard form, but is there any gaps from going from x to the 6th down to no x's? There are gaps? Yeah. Okay, so we don't have anything for x to the 5th, 4th, 3rd, or 2nd. So I'm going to have to put 0, 0, 0, 0 in. Okay, so I'm divided by this. This comes outside, up this L. Okay, I have a 1, and then x to the 5th is 0, x to the 4th is 0, x to the 3rd is 0, x to the 2nd, 0, x constant.
Wait, what?
What do you mean? Mr. Sharp, could you please elaborate?
Okay, so 6, 5, 4, 3, 2, 1.
Yeah.
So technically, if I were to write this all the way out, this could be 1x to the 6th plus 0x to the 5th plus 0x to the 4th plus 0x to the 3rd plus 0x squared plus 3x plus 4.
Fine.
But 0 times anything is just 0, so we don't have to put this. So we are missing that whole chunk. But we have to put the zeros in as placeholders. That's what it means. Does that make sense?
Wait, so
Why
for
do
every,
you need that?
Well, you don't need this whole thing, but you need to make sure you have placeholders with synthetic division.
so for every like
Zero is
gap,
a placeholder.
So yeah, zero is
Just a placeholder.
0 is your coefficient of x to the 5th. 0 is your coefficient of x to the 4th. 0 is your coefficient of x to the 3rd, x to the 2nd. It's your coefficient. It's your base number.
so you always need a 0 when it's not like 3, 2, 1 or.
Yep. Is that okay? So did I answer all those questions?
Yeah.
Yeah.
So are we ready to synthetically divide?
Are we like, are we just supposed to know that for the test?
Yeah, I think it's kind of an easy concept. But
It is, but it just takes long. I feel like I can just plug in 2 for x and.
Oh, dude, I would, and because 2 to the 6 is 2, 4, 6. You know,
Can you just plug in if you don't
2, 4,
want?
8, 16.
I mean, I tried.
I would, but if I asked to use synthetic division, I'm looking to test to see if you do synthetic division.
Okay.
But no, I agree with you. But I'm not going to always give you the most complex situation to show that you know how to do synthetic division, because what happens? You start dealing with fractions down here. Then am I testing you if you know how to do synthetic division, or am I testing to see if you can do fractions? That becomes the big argument. So with this problem, I agree 100% with you. This would be so much easier to have 2 to the 6 plus 3 times 2 plus 4. I agree with you 100%. I won't argue at all. But if on the test I said, hey, use synthetic division, I'm testing to see if you can do synthetic division, not tell me what the remainder is. Okay? So, let's do it. Comes down. 1 times 2, 2. 2, 4. 4. 8. 8. 16. 16. 32. 35, right? 2 times 35, 70.
Come on, wait. Why 35? Why?
Add these, combine them. All I'm doing, I bring that down. This plus, this plus, this plus, this plus. That was easy.
Yeah.
And then I finally have a number, and 3 plus 32 is 35. And then 35 times 2. So I get 74 for an answer, and if I didn't do it right, then this will show 2, 4, 8, 16, 32, 64, plus 6, plus 4. So that's 74 as well. Is this way easier to do? Yeah. Am I trying to get you to use a new solving method that works better in a more complex situation? This works great in real complex situations. Okay? It sucks in this situation. Okay? And again, I'm testing to see if you can do synthetic division. I'm not testing to... All right, would you please make sure your names are on your assignment, 6B, and if you're turning anything else in, pass that forward, please. And I gave you the purple sheets already, yes?
Yes.
Yay! Don't hand those in, just pass it forward.
Wednesday? Oh.
Don't hand those in and pass those back. Pass those back, don't hand those in.
Because that's the 2. That's the 2 only factors actually.
So just there's an X and it's 0.
Oh, in the mile.
Oh my god.
All right. Homework, yes, sir.
Homework.
It's here.
No, I can't. I'm really mad about
Give me
it.
the purple.
Zero
Thank you.
is the first.
Homework.
The 1 comes from the 1.
It starts at 5:30 and the game is at on the other side of town. Yeah.
Where are you stuck on that?
The 0 comes from the
On the email about that.
But the,
And like,
Where are you stuck?
okay, so.
oh yeah.
Wow.
Ask it.
Okay.
You're fine.
I know, I'm just trying to think of how I'm going to ask this stuff.
Are you stuck where the zeros are?
Yes.
Or are you stuck with where that whole spiel came from?
Yeah.
So you're good with the 1, the 3, and the 4, right?
Kind of. Yeah,
So that's a 1 here, a 3 here, and a 4 here. That's where those come from. But being it goes from x to the 6, being I don't have x to the 5th in there, I have to have a placeholder. Being I don't have x to the 4th in there, placeholder. Being I don't have an x to the 3rd, placeholder. X to the 2nd, placeholder. But then I have an x. Now I don't have a placeholder. So like this huge
those are
thing.
just placeholders.
Yeah.
All those 0x are just placeholders.
Yeah. See that? That's it.
I get this now. Okay.
Does that make sense?
Yeah.
Why is under the 332?
Because from here I went 16 times 2, I got 32. When I combine those together, I get 35. You're just adding them together.
Wait, so for every problem with this
Synthetic division?
do you need to do the placeholders?
Yes.
So you have okay.
If you don't do the place, so here's the thing that stinks. Was this a longer process than doing this?
Oh yeah.
Absolutely. Not a doubt in my mind. But if on the test I say, hey, do synthetic division, and I'm trying to make this, I mean, to me, this is a relatively easy problem. Like, where these start stinking, I'm going to divide by 5 over 6. So you're like, oh, I'm going to put 5 over 6 in here, and I add those, I get 5 over 6, and 5 over 6, and then I get 25 over 36. It starts getting nasty. Right? But am I trying to test that you can do fractions, or am I testing you can do synthetic division? I'm looking at the synthetic division. Your 5th grade teacher is testing you on the fractions. Okay? So, but these do get big. Yuck. They're gross.
Well, that's cute.
All right. So notes aren't too bad today, I don't think. We're going to be talking about graphing polynomials. Now, don't let this panic you. Don't be like, oh my gosh, this is horrible. We will be using the calculator a little bit. Actually, I'm going to pull mine up. And don't panic if you don't have a calculator with you at this moment. You don't have to come rush to the front of the room to get a calculator. It's not the most pivotal part of this lesson. All right. Could be. All right. So do we all agree that end behavior, pretty much for the most part, either goes to positive infinity or negative infinity? Either it goes up or it goes down. Some problems it can go up and down, depending on if it's raised to the 1st, 3rd, 5th, or odd number. And then the end behavior goes to the same place when you have x squared, x to the 4th, x to the 6th, x to the 8th. Does that make sense? Or did I say wrong?
No.
Oh.
No.
Okay. Because I might have slurred, you know me. All right. So a new thing that we're going to talk about is something called relative maxes and mins. But don't let this be like, oh my gosh, this is impossible. You know what a relative max or min is? It's like the absolute max and min is infinity and negative infinity. That's the end behavior. It's what happens in between. So let's say I had a graph that looked like this. Whoops, it's better when I have the writing pencil. If I have a graph that does this. Okay? This max is going to infinity. This max is going to negative infinity. Agree? I have a relative max here, here, and here. I have a relative min here, here, and here. Okay? A min is a bottom turning point. A max is a top turning point. That's all it is. Okay? Don't panic. There's more to the lecture than this. All right. So, graph the function by completing the following. Graph all x-intercepts, clearly marking the points on the graph. Okay. Sounds good. So what would this give me as a 0?
X plus 2.
Positive 2, right? Yep. You go x minus 2 equals 0, so x equals 2. Is anybody not sure about that? Okay, now, there are 3 things that can happen with these polynomials in graphing. They can go right through the point, they can bounce off the point, or they can wiggle through the point. And we're going to cover all those right now. Okay? What 0 is this? -1. Okay? So far, does everyone agree that if I had written this, this would be x minus 2, x minus 2, x plus 1? Does that make sense? So we have 2 x minus 2's that are taking place. Agreed? Sometimes, like maybe in Algebra 1, they might have called it a double root. Okay? So that if I were to multiply out x minus 2 times x minus 2, I'd get x squared minus 4x plus 4. Okay, that's a perfect square trinomial. Okay, so this is a double root. Okay, so graph any y-intercepts. Ooh, let's figure out the y-intercept. Nope, it's not 0. Watch, ready? How many of these do I have? 2. So -2 times -2. Positive 4 times 1.
4. Huh.
You see how I just did that? Am I multiplying out this whole problem?
No.
Am I getting this to like x to the 3rd way out? No. I'm just utilizing some tools that I recognize. Okay, so roots, ordered pairs, aka call them zeros. Still with me? So this is a 0, this is a 0, this is a root, this is a root. One of them's a double root. This is a double root, yes? Make sense? No? X minus 2 quantity squared is called the double root because it happened twice. Okay? So if I have an even number, that I'm raising a quantity to, or if I'm just raising a letter to, if it's to an even, this creates a bounce.
What?
It's going to bounce. And you're going to see what this means in a moment. This is just to the first power, okay? So if this is to the first power like that, does everyone agree that x plus 1 quantity to the first is the same thing as x plus 1 quantity?
Yep.
Make sense? This crosses. Okay? Means it goes right through it. So let's see if you can figure out what I'm doing. So this would have been, if I had graphed this would be an x to the third polynomial. I don't have any negatives out front, so this is what it should kind of look like for the most part. Okay? Where's my double root? What number? 2. It's going to bounce. This is what this is going to look like. Can everyone see the bounce so far?
Yeah.
See the bounce? Now, I'm not quite sure exactly what the transition is right here, but here's my bounce. Notice it didn't go through it, correct? It didn't cross it. Okay, so this probably comes up like this, somehow changes directions here, and then comes through that. Goes right through it. It crosses it. It crosses it nice and goes, it doesn't have any like, hey, doesn't have any hula or anything like that. Wiggle. That's where the wiggle is going to come in. Okay?
So it starts on the right side?
So remember how I said, end behavior, if you have this being a positive number outside, if it's not negative, our end behavior on the right is going to be positive. Okay? But it bounces here because that's called a double root. It goes up, changes direction, comes back down. We found this because we multiplied our constants together, and then it goes right through there.
Multiply constants together, so you multiply.
Negative 2 times negative 2, 4. 4 times 1, 4. That gives me my y-intercept every time. Okay? The reason that works, think of what your y-intercept is. It's 0, comma what? So you're going to plug 0 in here. 0 minus 2 is negative 2. Negative 2 squared, 4. 0 plus 1, 1. 4 times 1. So that's why you get 0, comma 4 as a y-intercept. It's just another point to have up there. It's not a solution. It doesn't do anything like that.
But why does that create the wiggle?
Yeah, we haven't got to a wiggle yet. We're getting there. We'll get there. All right, so did this bounce? Yes. Did it wiggle? No. Did it cross? Yes. All right, is everyone okay seeing the bounce?
Yeah.
Is everyone okay seeing the cross?
Where's the cross?
Where it goes right through at negative 1.
Wait, so what is a wiggle?
So there's no wiggle. I don't have a wiggle yet.
Okay.
Okay? So then I have a local max, and a local min. Local max, local min. Local max is here. That's a max. Local min here. So it's called a local min. So local meaning is changing directions. It's going from up to down, or it's going from down to up. That's all.
That could have been anywhere, right?
Right. So I'm not totally sure where this is exactly. I'm not too concerned of it right this very second. I know this one right here for sure because it bounced there. I know exactly what that is. Okay? So let's talk about just the local min for right now. The local min is going to take place at 2, 0. Is it always a root? No. But we're going to talk about where we're going to get this. We'll find out this local max here in a sec. We okay so far? Yeah. All right, so what I'm going to do, I want to go to my calculator. Okay? Don't worry if you don't have one. You can just watch. Okay? You don't need to have it out. Okay, so I'm going to graph this function. So x minus 2, x plus 1. So I had x minus 2, and that was squared, right? And then I had x plus 1. Is that what it was?
Yes.
Thank you. Does everyone feel comfortable with that?
Yes.
Let's just do a zoom standard, so a zoom 6. So can I see on here this min here?
Yeah.
Can I see this max? It's somewhere in there. Is it exactly that point? I don't know. Let's figure out if we can figure out that max. Okay? So our favorite key on here is second calculate, because we want to find a minimum, we want to find a maximum. We were using the minimum and the maximum to find the vertex, right? What is the vertex? That's the turning point of a parabola, where it goes from down to up, or up to down. Okay? So let's find the minimum first. I want to find the local minimum. So I'm going to take this. Does it look like I'm on the left side of this minimum?
Yes.
Hit enter. Does it look like I'm on the right side of that minimum?
Yes.
So that's the same thing as 0. 1.36 times 10 to the negative 11th, it's 0. So at 2, 0. Okay, the reason why this doesn't work is TI still hasn't figured out to put squares as their pixels. They have rectangles. All right, let's find the local maximum. Second, calculate, find the local maximum. Local max, I'm going to go, that's my max right there. Am I on the left side of my max?
Yes.
Am I on the right side of my max?
Yes.
Yes.
So that's pretty darn close to 0. So it's 0, 4. That's scientific notation. Negative 8.2 times 10 to the negative 7. So that's 0.6082. It's close enough. So 0, 4 is our local max. Okay? So local max is at 0, 4. Done there. All right. So I think we're at, I know we have more to this. I know that we have more to this. Do me a favor. Do me a big favor. Do me a big favor. Flip your notes to the very back page. Notice how it's somewhat blank?
Somewhat.
There's like a square on it and a date at the top and then the title.
Yes.
I had to say that because someone's going to do other stuff on there. Okay. Would you please, just for me, this is your only homework for tonight. Only homework for tonight. Log into DESMOS.
Oh, no.
Okay.
I hate that.
No. All right, so just log into this. It's as easy as this. If you can't figure it out, it's going to be at the end of the video. So if you go into DESMOS.com, okay? That's what you're going to get to, and you hit start graphing, okay? But DESMOS.com, and then I want you to practice graphing. And I want you to graph the following. Y equals, you're going to need to put y equals x plus 2 squared, x minus 6 squared, and plus, and that's it. So try that one. So that's going to be 4th. And then also try and graph this one. Graph for me those two. And just on the back side of that page, when you come back tomorrow, I want you just to talk to me about what these graphs look like. Play around with DESMOS where you can expand it and contract it, because on DESMOS, we will have DESMOS as our graphing option on our end of the semester, the first capstone test. I want you to feel comfortable with DESMOS.
Can we do that in our calculator though?
You can't do the test on your graphing calculator, no. That's the only limitation we have. That's why I want you to take a look at DESMOS. And will you please bring these notes back tomorrow so we can finish them?
We're not doing
But that's my only homework. That's my only homework for tonight. Right there, and bring this back.
So not
back.
60?
Nope. Just do this for your homework right here. That's all I need you to do. And write down on the back of your notes, and then bring your notes back. Sound good?